Look here, this is the California town of Maxwell with a population of about 1,000 people. Actually, there's nothing special about it, except that soon they'll pour 475 million gallons of water into a nearby valley and spend almost $4 billion on it. At first glance, it seems like this is weird, since California is literally a drought state. It's totally normal here to save water for several years in a row, so there's enough to drink and enough to wash with. Farmers also need to save, so there's enough to water their crops. In addition, California is officially introducing different restrictions on water usage. And still, the state authorities are okay with the fact that a huge amount of water will be spilled somewhere around here in this arid area. Yes, it's truly odd. But this is how California intends to survive the never-ending drought. So what's the plan? Let's figure it out now. There are big problems with water availability in the state, largely because California has several deserts that cover a significant amount of land. In California, there's the Mojave Desert, which covers 13,500 square miles, where an average of 2 to 6 inches of rain falls each year. The thing is, the rain does no good. Temperatures in the desert rise above 100 degrees Fahrenheit, causing all the rain to evaporate quickly. There's also the Colorado Desert, about 10,800 square miles in size. It gets a bit more rainfall, but the issues are the same as in the Mojave. It's hot, and finding water is incredibly difficult. And this is the huge Great Basin Desert, which spreads its dry lands over almost 200,000 square miles, some of which are in California. What about precipitation? On average, between 6 and 12 inches fall per year, which is exactly why the area is desert-like. Anyway, the state's location isn't exactly perfect for getting enough water. But that's not all, because at certain times, things get even worse. In these shots from July 2021, Gavin Newsom, the governor of California, is asking all Californians to use 15% less water. Surprising? Not really, because before there were not just requests, but official restrictions. Let's go back to April 2015. Back then, Governor Jerry Brown issued an order that required cutting water use in cities by 25%. Why is all this happening? To understand, let's take a look at this graph. There are times when drought levels are normal, and then there's the period from 2014 to 2017 when 60% of the state experienced exceptional drought. In fact, all of California was dealing with drought to some degree. After that, there was a quiet period, and then a new phase began in 2020, lasting until about 2023. Things are less critical here, but the issue is clear. The state sometimes has way less water than it normally does. It's obvious that the restrictions are aimed at preventing a major water shortage as the rain doesn't fall in the right amounts. Look at these shots. This is also California during the last drought period that started in 2020. There was literally a flood. Hundreds of millions of gallons of water fell from the sky, causing destruction and human casualties. And this is not the only case. The state periodically experiences catastrophic floods right in the middle of another drought. Because of this, emergency situations caused by too much water arise right in the middle of emergencies that were declared due to a lack of it. A classic California paradox. The question comes up, can we use rain to reduce the freshwater shortage during droughts? In fact, this question came up in California back in the mid-20th century because at that time, dry periods alternated with massive floods. That's when the California State Water Project, or SWP for short, was created. As part of the project, a huge system was built, which is considered one of the largest in the world. In particular, Californians built the San Luis Dam, which created the reservoir of the same name. It can hold up to 792 billion gallons of water. One of the most famous and largest reservoirs in California, Lake Oroville, was also created as part of the SWP project. A dam was built blocking the Feather River. As a result, California now has a reservoir capable of holding 1.1 trillion gallons of water. All the water in these and other reservoirs moves through a vast system of pipes and channels. This is the California Aqueduct, the key feature of the project, and also a massive system that delivers fresh water from one part of the state to another. The transport network stretches 460 miles and can carry 98,000 gallons per second. At the southern end of the aqueduct, you'll find the Edmonston pumping plant, which is rightly considered the centerpiece of California's entire water system. The plant was awarded the title of the most powerful water lifting system in the world, if we don't count pumped storage plants. Do you know why it got this title? Check this out. There's the Eiffel Tower, which reaches 1,080 feet in height, including the antenna. The Edmonston station could easily pump water through that. What's more, the pumps could handle almost 2 French landmarks. They pump water up to a height of 2,000 feet across the Tehachapi Mountains. Overall, the SWP system is good, so it should work fine, collect enough water, spread it all over California. However, it was built in the middle of the last century, and a lot has changed since then. For example, the population has more than doubled, which means water consumption has also increased. Plus, the growing number of people living in California, the state's become and continues to get even wealthier. New companies are opening, industries are developing, agricultural areas are expanding. All of this leads to an increased need for water, since it's one of the most important resources needed almost everywhere. In short, the system is no longer able to take in and distribute enough water to meet the needs that arise in excess amounts during heavy rains. That's why they decided to build something that would allow collecting more water. The site's reservoir not far from Maxwell. The location was chosen largely because nature here seems to have created a kind of bathtub bounded on 2 sides by hills and mountains. Almost no one lives in the area required for the reservoir, so there won't be any massive resettlement programs. As for the vegetation, it's just small bushes and a few trees. No need to deal with lawsuits from environmental groups. In short, the place is perfect in every way. The preliminary research was done from 1996 to 2014, meaning it took 18 years and cost $50 million. That's pretty solid preparation. As we've already mentioned, this is a sort of reservoir, so the water should be contained by the walls or the landscape. There are places where the mountains won't be able to hold the water, so the plan is to build 9 small dams as well as 3 larger structures. 2 dams called Sites and another one to be named Golden Gate. Will these dams set any records? That's not expected, since the main Sites Dam will be 265 feet tall and Golden Gate will be 285 feet. For comparison, the dam that created Lake Oroville is 770 feet tall. But it's the tallest in the U.S., so many similar structures have a long way to go before they reach that. But the Sites Reservoir itself will make it to the top. The planned reservoir will stretch nearly 13 miles from north to south and 4 miles from east to west. When full, its depth will reach about 262 feet from the surface to the bottom at its deepest point. All that'll be enough to hold up to 475 billion gallons of water in the valley, making it, by the way, the 8th largest in all of California. But the reservoir has another feature: Sites won't block the flow of any river. Thanks to this, it'll be the first of its kind in California. It's a kind of flexible solution that'll get water by diverting it from the Sacramento River. Is there a difference compared to typical reservoirs formed by blocking a river? After all, they divert water the same way. Yes, because Sites will take water from the Sacramento River only during high flows and only after all other water commitments and regulations are met. And then Sites will release the stored water during dry periods. So this is the perfect solution for California. With the reservoir in place, rainfall won't just run off without benefiting Californians. When a storm rolls in with heavy rain, Sacramento's water level goes up, and the extra water, which isn't needed anywhere else, gets diverted into Sites via pumping stations, small reservoirs, and a system of canals and pipelines at 32,000 gallons per second. Then, when the next drought season hits, the reservoir releases its water to meet California's needs. By the way, the creators say that 475 billion gallons of water is enough to supply 7.5 million people for a whole year. Sounds pretty great. A state struggling with water shortages will finally have enough. However, the Sites Reservoir has more to boast about than just that. Construction often has a bad impact on the local environment. In the case of Sites, a big part of the transportation infrastructure, including canals and pipelines, will be existing facilities. In other words, what's already built will be used with no extra negative impact. Sites is also going to collect and store most of the water specifically for the environment, helping to sustain freshwater systems. What's more, the environment is expected to become the biggest consumer of the water planned for storage in the new reservoir. It's worth noting that Sites will be the first facility of its kind in California. And here we have salmon. Dams are a constant issue for them since many species swim upstream to spawn. A blocked river isn't exactly the best place for that. That's why so many environmental groups oppose the majority of dams. Even more, the situation with salmon in the Sacramento River itself has long been debated by a host of environmentalists and actively condemned by ordinary people. So like we said, the Sites Reservoir isn't going to block the river, which means it won't get in the way of the salmon at all. And according to its creators, the positive impact on the species population doesn't end there. For example, sites can work together with Shasta Lake to help store and improve the cold water that the endangered Sacramento salmon desperately need. So does that mean activists will finally be happy? Unfortunately, no, as salmon still have a lot of problems. So for example, even though the reservoir won't be sitting on a river, the water isn't just going to appear out of nowhere, it'll be coming from Sacramento. What's more, from time to time, sites will be taking up to 60% of the total flow, which could harm the salmon. And yeah, environmentalists aren't just worried about this one fish, as rivers have more than just salmon in them. Sites could also impact the habitat of 23 other vulnerable wildlife species. Now let's imagine that during a fierce storm, the reservoir filled up with water that would usually just flow out. Sounds great. But don't forget about the location of sites. It's California, where the temperatures are always high. Water will evaporate, so there's no avoiding losses, and the losses will be significant. According to the organization Friends of the River, about 9.7 billion gallons of water will evaporate annually from sites, and thus from Sacramento. In 2023, Friends of the River teamed up with the movement Tell the Damn Truth, got funding from Patagonia, and released a report that brought attention to another issue: emissions. According to the report, sites will emit around 362,000 metric tons of CO2 per year throughout its operation, including demolition and draining. The most significant source will be methane, which forms as organic matter decays in the reservoir waters. In short, there are some issues, but they don't outweigh the benefits of the future reservoir, which will help save California from drought. Now it's just a matter of waiting a bit to see the positive impact. The construction's planned from 2026 to 2032. But let's think about it. Even though this reservoir will take the excess water after heavy rains, it's still not a solution to all the problems. For this reason, the state's looking for salvation in other directions, like wastewater. Of course, the state takes care of treating this kind of water. As of 2025, California puts out over 224 billion gallons of purified water a year. That's definitely enough for a lot of people. But the main consumers aren't residents. The treated water is actually great for other uses. For example, treated water works for farming, which overall takes up 80% of California's developed water supply. So treating wastewater means more clean drinking water is freed up for people and other uses. And here in our video, groundwater comes into play, which in California is also replenished with treated water. The state even has several large-scale operations where treated wastewater is pumped straight into aquifers. For example, a facility in Orange County treats and injects about 98 million gallons of water a day. As a result, when there's a surplus of water, the state builds up reserves that can be used during dry spells. Naturally, wastewater's made its way into the industry too. In California, for example, it's used in pulp and paper plants, cooling towers, and power plant boilers. Used wastewater can also be used for mixing concrete and other non-drinking purposes. In fact, it's a pretty cost-effective solution since treated water is cheaper than raw, fresh water. Plus, there's no need to purify it to really high standards using complex and expensive equipment. Everyone loves saving money, so a Californian's wash cycle leftovers could totally find their way into some product. If we're talking about the biggest water treatment facilities in California, there's one with a really cool name, Hyperion, located in southwest Los Angeles, and it happens to be the city's largest wastewater treatment plant. Want more? Well, it's the biggest one by volume west of the Mississippi. Still not enough? Hyperion is actually one of the largest facilities of its kind in the entire world. As of 2016, the plant could treat 449 million gallons per day, and that's not even its peak capacity. When it rains a lot, it can handle a bit over 792 million gallons of water per day. It's hard to wrap your head around that, but let's give it a shot. Today, we looked at the future Sites Reservoir, which will hold 475 billion gallons of water. So if Hyperion were somehow hooked up to fill it, it could handle the job all by itself in about 600 days. That is less than 2 years. And of course, that's assuming the water from the plant was the same quality as the Sacramento rivers. For a state that's constantly dealing with water shortages, this is a big deal. But California isn't slowing down when it comes to making strides in water reuse. The state wants more water, so by 2030, it plans to reach an annual production of purified water amounting to 660 billion gallons. That means the volume of recycled wastewater used anywhere needs to almost triple. Bold plans, but they're actually starting to come to life. A great example is the Donald C. Tillman Water Reclamation Plant in Los Angeles. Right off the bat, it's worth saying that the plant is not your typical one. The treated water doesn't travel far through pipes to other factories, farmland, or anywhere else. It gets poured straight into the lake in the nearby Balboa Park. No, this doesn't mean everyone's heading to the park to grab some water for their needs. The water from the lake eventually flows into the Los Angeles River, and the water produced at the plant actually makes up most of the flow of the river running through the city. Right now, the plant processes 79 million gallons of wastewater per day, producing 26 million gallons of recycled and ready-to-use water. However, the station is quite old. It was opened back in 1985, and its efficiency isn't exactly impressive. That's why they decided to carry out a $740 million upgrade. According to preliminary data, this will allow for treating 20 million gallons more, meaning that around 99 million gallons of dirty water will be coming to the plant each day. As a result, the total amount of treated water will also increase, which will go toward meeting various needs. And this is not the only upgrade, just an example of how California is moving forward in this field, trying to become a state less affected by water scarcity.